Discussion on the risk and returns portion of finance, and we try and understand how are returns really distributed in this particular video. Right now, to understand that, we are supposed to now talk about a particular concept called normal distribution. So, what exactly is this normal distribution? Right? So, in finance, it is assumed that returns of any kind of stock or any kind of asset are distributed normally. Now, this is an important concept because mathematically this makes sense, but does it hold true in real world is something that has to be tested. So first, let's understand what this term normal distribution means. It's also known as a bell curve. You might have studied it in other subjects or other areas. And the idea is that almost the bulk of the population or a bulk of a sample that you're trying to evaluate for any parameter lies near the average, and it's centered around the average, right? Take, for example, a class of students, right? And just to kind of ideally look at what kind of height everyone has, let's say the height of the students is what we are looking at as a parameter, right? Now, when you look at the height of the students, there would be, let's say, an average height, and assume that the average height is somewhere around, let's say, 5 feet 7 inches, just for argument's sake, right? Now, it's natural that most of the students will fall around this region. So if I plot a point here on a curve that says this is, let's say, 5 feet 7 inches, this point, and I try and plot the number of students on. So let's plot two lines. One line is the height bit. The other line is the number of students who come here. So that's the number of students. So where do you find most of the students will be? Most of the students will probably be centered around here. So if you keep plotting the number of students, most of them will be between, let's say, 5 feet 4 inches and 5 feet 9 inches and 10 inches, right? Then some will be shorter, some students here, and then you find some other students will probably be slightly taller, around 6 feet and probably more than that. So if you were to plot a curve, the curve would probably appear something like this. It is centered around the mean, right? So the mean is where most of the observations will lie, but there are a few people who will be on the right side and a few on the left side, right? So technically, with this data, you could do some sort of a calculation of average, and you could find out what is the standard deviation, right? We can do those calculations. Standard deviation can be calculated as x minus x bar whole square, summation of this divided by n, and we take the under root of this. We can do that, right? So practically, if we do that and we try and see how does this centering around the mean work, this kind of a curve, which looks like a bell-shaped curve, is called as a normal distribution. What does it say? That most observations are around the mean, right? And some observations are away from the mean. Now, there are a couple of interesting things that come around this, and we would want to write them down and be clear about those. The first important part that comes here around this curve that you see is that this curve is symmetrical. What do we mean by symmetrical? The number of observations on the left side of the average is almost the same as the number of observations on the right side of the average, right? So one part that is important is that most of the observations are around the mean and some are away from the mean. And the second part of the observation is that the curve is symmetrical in nature or broadly symmetrical in nature, right? What does that mean? That means that effectively you have the same number of observations below the average being the same as mean. So I'll keep using the terms mean and average interchangeably. So the number of students who lie below the mean is almost the same as the number of students who lie above the mean. Now, in real life, that may or may not always hold true, but for a large sample size, in a class of 20, this may not be true, but in a class of 200, there are chances this will fall true. In a class of 2000, this will almost always be true. So as you increase the sample size, the normal distribution starts becoming more and more prominent and evident. The chances of you witnessing normal distribution are more and more evident, right? And now this normal distribution, which is a symmetrical distribution, which says that the number of entries on the left side of the mean are almost the same as the number of entries on the right side of the mean, broadly speaking, is found across the length and breadth of the world. There are a lot of things which follow normal distribution: height of students, weight of students, average speed of cars on a highway. You'll find that almost a lot of these segments would follow this. Now, in finance, we assume that returns of a stock, remember, not prices, returns of a stock. So if the price is 100 on one day, 102 on the next day, 103 on the next day, these prices is not what we are considering. We are considering the return, which is 2% on the first day, correct? And then approximately 1% on the next day. These are returns. Now, these returns are supposed to be distributed normally. So if I do a plotting of the returns in finance, the distribution will probably become symmetrical. Let's see this. So what is being said is that if you have a stock and you look at returns, and let's say this is the average return, and you look at returns for, let's say, 200 days, right? And you try and plot where the return number is. Most of the observations will fall around the mean. Then there will be some days when it will be significantly below the average return, and there will be some days where it will be significantly above the average return, right? But most of the days, this would be around the average. If you draw a plot of this, it should appear like this, right? Which is a sort of a curve that's again inverted. It's like a bell-shaped curve, and it would be symmetrical in nature. Now, remember, we are talking about returns of stocks, and we are just at this point of time putting in place the theory. We are yet to test this, right? So the theory states that this should exist. Most of the days, the return will be around the mean. The practice may tell us something else. So we'll look at trying and testing what the practice means, right? So let's first look at what happens with Nifty. What is Nifty? Nifty is the top 50 stocks in India, companies in India on the National Stock Exchange. If you take these top 50 stocks and create an index out of it, that index is called the Nifty 50 index. And there is a value of this Nifty 50 every day. So we are going to look at this value, and we are going to try and identify how many days, what is the average return, right? We can find out the return on a daily basis. How many days the return is below the average and how many days the return is above the average. For this, we're going to use 2 years of data, right? So we are using, let's find out. We are looking at Nifty index values. Where do you find it? You can find it on the website of nseindia.com. You're looking at 2 years of data. You will find the returns, and we'll find out what is the average return and what is the standard deviation of those returns. And then we test the symmetry, and we look at some other data points. So we'll try and find out what is the distribution like, right? So at this stage, we're just going to see and check if the symmetry exists, right? Then we will try and find out what is the distribution broadly going to look like. So let's try and test the symmetry bit. So for this purpose, what you see here is the date starting on a particular date, which is 6th March 2014, and this goes on till 4th March 2016, and we're looking at 2 years of data. In column B, you find the data around the values of Nifty, and in column C, you're basically calculating what is going to be the return on a day-to-day basis. How do you calculate return? You basically take today's value minus yesterday's value. You divide this by yesterday's value, and that should be the return value that we get, correct? And I double click it, all the values come here. Now in these cells, we calculate the average, right? And we calculate what is the standard deviation. So how do we find the average? Average is found by C5 to C495. Standard deviation, we use the formula STDEV. We can use STDEV dot P. We have seen earlier what is the difference. There will be a minor difference, but in the case of 4 data points, the difference was huge. In this case, how many data points are we looking at? We are starting on row number 4, and where are we ending? We are ending on row number 495, right? So there are two, so that's the date start, and if you look at the start of returns are starting in row number 5 until 495, right? So we are looking at data which is 5 and 495. So on one end we have 495, on the other hand we start at 5. So the data should be about 491 days. We have 491 days of data that is available with us, correct? Now let's try and check if I create some sort of a distribution. What is the average? The average is 0.04. Just ignore this for a moment. I'm going to kind of look at the data points as we go along, but this is the average, right? We also use a function in Excel to just test for it. At this point of time, we don't need to worry too much about it. The function is called frequency, right? We can also use a function called count if. So we can find out count if the return is greater than 0.04%, how much of it is greater than 0.04, and how much it is less than 0.04. That's the first test of symmetry. How many data points out of these 491 data points are above the mean and how many are below the mean, right? Now you see this here. If you add all this up, what is the sum of these? That is 246. These are the data points which are below 0.04%. So how many? 246. Let's write that down here. How many would be above this? So that's all these data points. So I can sum all these up. How much is this? You find that is going to be equal to 491 minus 246. That's 245. So out of 491 data points, 246 are below the mean and 245 are above the mean. That proves our point. That effectively we are looking at a scenario where 246 data points are below the average return and 245 are above the average return. So broadly, we have established that the curve looks symmetrical. Same number of entries below the mean as there are above the mean, correct? That's the first observation that we have, that symmetry, at least on the average level, is there. Right now we have still not tested whether the curve is completely symmetrical, right? So if this is the mean, there is a possibility that there are a lot of entries here, and then you have something like this kind of a curve. So we have and it's quite possible that the number of entries here is the same as the total number of entries here. So we have not tested the entire symmetrical bit, for which let's dig into a little bit more detail about normal distribution. What exactly is normal distribution, right? Now, as per theory, if I create a curve, and let's create the curve again here. So if we have a curve that is centered around the mean like this, that's a bell-shaped curve broadly, and it does not meet here. It keeps, you'll always have an observation that is significantly away from the mean. So what's the mean? The mean is here. Now what I do is I take standard deviation. So what is the standard deviation? Let's take a standard deviation number as SD, right? Standard deviation is also denoted by the Greek letter sigma. So sigma is a definition for standard deviation, right? Now we add a standard deviation here. So mean plus 1 standard deviation, then we do plus 2 standard deviation, then we do plus 3 standard deviation. I can keep doing that. Mean is, remember, 0.04%, and then standard deviation is 0.98. So 0.04 plus 0.98 plus 0.98 plus 0.98. I can keep doing that, correct? And I also do a subtraction of minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation, right? Let's understand what these numbers would be. So 0.98 is the standard deviation number. So we will get these numbers as approximately 1.02%, correct? Approximately. Then we get the number as approximately 1.99% or 2% approximately, and 2.97%. We keep adding. 0.04 is the mean, plus 0.98 plus 0.98 plus 0.98. On this side we do minus 0.98 minus 0.98 minus 0.98%, right? So on this side this will become minus 0.94%, then again minus 1.92% approximately, and then again minus 2.90% approximately. You just keep moving on the left as well, correct? Approximately. I've just put in numbers. Now you try and find out on how many days is the return between this point and this point. We have the data. We can actually just try and find out on how many days the return is here. All we need to do is use COUNTIF. We can use a COUNTIF function, right? Count if the return is less than 0.04%, count if the return is more than 0.04%. You can use multiple conditions as well. So I can say, I can find out count if the return is less than 0.04%, and then I can count if the return is less than minus 0.94%. And then I can find the difference between these two. That will give me this data, right? We can get this data. Now, in terms of the normal distribution process, if you look at what is the normal distribution and what does it stand at, again, we're talking about theory. We're talking about theory. If I actually plot the number of observations between plus minus 1 standard deviation from the mean, which is this to this shaded portion, this entire portion is what we are looking at. It is said that roughly 68% of your total observations will lie here, right? Roughly 68% of your total observations lie here. If you look at 2 standard deviations and you look at this data, obviously the entire 68% will be inside this. It says roughly 95% of the observations lie between plus minus 2 standard deviations, right? So what is the theory? The theory says that between 1 standard deviation negative and 1 standard deviation positive, if you look at this set of data, close to about 68% of all observations will be between plus minus 1 standard deviation, right? Approximately, if you add all this as well, and you look at the data between these two, obviously that entire 68% falls inside this. Close to 95% will fall under 2 standard deviations. And if you extend that to 3 standard deviations, close to 99% will fall in 3 standard deviations. So if you are looking for data for 200 days, roughly 134 days, which is 136 days, sorry, which is about 68%, roughly should fall between plus minus 1 standard deviation. Roughly 190 days will show returns between minus 2 sigma and plus 2 sigma. And roughly 198 days will show returns between minus 3 sigma and plus 3 sigma. That's important. Let's test this. Right? So what we are seeing here is now we just keep adding standard deviations. We keep subtracting standard deviations. Right? So we get the ranges and we find all the values as what is between 0 and minus 1 standard deviation, what is between 0 and 1 standard deviation, minus 1 and minus 2, minus 2 and minus 3, below minus 3, plus 1 and plus 2, plus 2 and plus 3, above plus 3 standard deviation, right? Remember, we are not required to calculate it here. All we are doing is we are trying to see if normal distribution and symmetry exists. So one thing that we need to do is find out how many of, so let's look at the symmetry first. So I will select this set of data points. So let's select this set of data points and let's try and plot a chart. Right? You see this chart? Look at this chart. Right? Let's try and understand this chart a little bit. If you look at this carefully, does it resemble a sort of a normal distribution that we had just seen? Does it resemble? This is where the mean would be, roughly, right in the middle. Correct? So it does seem symmetrical. It does appear symmetrical from what we have just plotted. All we have done is number of days that are there, in terms of the returns, below 0.4, above 0.4, etc. So that's the chart bit that we have seen. It shows normal distribution, right? Now let's try and check whether that 68%, 95%, etc. hold. So these entries are the number of days in that range. So how do you interpret this? There are 3 days. There are 3 days when the return is below minus 3 standard deviation. There are 178 days when the return is between 0 and minus 1 standard deviation. Right? So I can find out if you add all these up, this would add up to the total, which is 491. So how many days is the return below 3 standard deviations? Can I calculate the percentages? And I will have to kind of freeze the 491 bit because I have to find the percentages on every bit. So now let's find out the percentage returns that are between minus 3 and plus 3. That's this one, right? Let's shade this yellow. The yellow shaded cells are the number of returns that are between minus 3 and plus 3 standard deviation. What is the sum of all these? 99%. We said 99% of the observations fall between minus 3 standard deviation and plus 3 standard deviation. Correct? Now let's look at this one. What is this shaded portion now? This is between minus 2 standard deviation and plus 2 standard deviation. What is the sum that we see? Around 95%. So the theory holds here as well. It is approximately 95% here as well. And the third one is, let's add this one, which is between minus 1 and plus 1. Now here the theory deviates a little bit. Our sum says 71%. The theory says 68%. Not too far, but practically it seems that not only is it symmetrically distributed, it broadly follows what are the basic tenets of a normal distribution. So we have checked on Nifty and we say that it is symmetrical as well as it broadly follows normal distribution, right? That's an important understanding for us because then basic concepts of finance start applying here. And that is the most important learning that we have at this stage, that stock returns or index returns or asset class returns are assumed to be distributed normally. And it seems from the practical data that what we studied in theory is more or less correct. What we studied in theory around normal distribution is more or less correct. We see that nifty. So theory and practice are now meeting each other in this case, and that is an important observation for us. This distribution of normality is going to have wide implications in our understanding because now we can use the risk and return framework to understand this more optimally, right? Next section onwards, we start introducing the concept. Right now, we've looked at only one individual security, which is the Nifty in this case. Now we start introducing the concept of diversification. Let's say you add two stocks to the portfolio. What does that do to the overall portfolio risk and return? That's going to form the basis of what is called as the portfolio theory or broad diversification benefits. It was important to understand the normality principle first. That's why we kind of discussed this. We now end this particular session with this question that you have to answer. Explain what you understand by normal distribution, and does it hold true for stock prices or stock returns?